Yeah. Ritya and Tanishka. Are you able to hear me?
Yes,
Yeah.
sir.
Okay, just shall we get started?
Sir, the test is tomorrow, right, sir?
Yeah.
Okay, sir.
So what is the answer for this? A ray of light is incident on a plane mirror, making an angle 90 degrees with the mirror surface. The angle of reflection of the ray will be
0 degrees.
why? Because the angle of incidence itself is 0 degree. So answer will be 0 degree. Three, four. Okay. What is the answer for this one? Which of the following is true? A concave lens has 4 diopter. A concave lens having 4 diopter power has a focal length of 0.25 meter. Is that right?
Sir,
Sir, it's option D, sir.
A convex lens having 4. Why is it so? Why is the first one wrong?
Sir, because the focal
length
the concave lens cannot be positive, sir.
It should be negative. And here, what is the mistake? And the second one, what is the mistake? This.
Again, the focal length is positive, sir.
So convex lens cannot have the power in negative. That is wrong. So fourth option is right. Correct. So light enters from medium A to medium B as shown in the figure. The refractive index of medium B relative to A will be. So refractive index of B with respect to A, that is mu B divided by mu A, is how much?
Greater than unit.
If you observe, the ray is traveling from
rarer to denser medium.
rarer to denser medium. So denser medium's refractive index divided by the rarer medium's refractive index is going to be greater than 1. So greater than unity. Answer for this one.
Option B.
Option B. What is the question number? 18. Option B is right. So refractive index of colorless volatile non-polar solvent is 1.24 to the refractive index of solid ice cube. The unmitigated refractive index of the ice cube is 1.31. Means it's absolute refractive index. So refractive index of the solvent is 1.24 and the refractive index of the ice cube is 1.31. Enumerate, find the unmitigated refractive index of the non-polar solvent. So refractive index of solvent by ice is 1.24. Is that right? So what is the answer?
1.6244.
Okay, that's right. So 1.6244. So convex lens is something repeated. Answer should be 2.5.
Yes, sir.
Yes, sir.
100 by 40, no? So whenever they've given you the focal length in terms of centimeter, you should write the power as 100 by f. So answer will be 2.5 diopter. Answer 20th.
1 point.
Point.
When red, blue, and green light coming parallel to the principal axis fall on a convex lens, they will converge on the axis at.
1 point, sir.
1 point.
Actually, the answer is 3 different points. Why? Because refractive index depends on wavelength. Okay, refractive index depends on the wavelength. Since the wavelength of red, blue, and green light is going to be different, then the focal length is also going to change. Okay, so just give me a minute. I have to
The
put this
focal
off.
length will differ.
Yes, it will. So make a note of this point. It will.
Sir, how I thought focal length was R by 2, which how will that change?
Yeah, sorry, Narayani, I had a call. You were asking something. You thought F is equal to R by 2.
Yeah, if F is equal to R by 2, then how will it be different?
No, that's not the case here. When all the three are going to be incident at the same on the same lens, right? The nature of the lens is going to vary. Actually, this concept is not a part of your syllabus. You learn it in your 12th standard. Okay, I don't want to tell the name of, give you the mathematical equation. The refractive index will change according to the wavelength. Since they have different wavelengths, they will fall at different points. That's the meaning. Okay, there is something called as Cauchy's equation. Okay, where this one will change the refractive index of the material according to the wavelength, because you would have not learned this concept, did you? See, for example, if I take a ray parallel to the principal axis, right? So this is the first refracting surface. Due to the first refracting surface, you would have had the image formed somewhere here. Narayani, are you there? You would have had the image formed here. But what would have happened is, since this ray which has got bent, right, will undergo one more refraction at this point.
Yes, sir.
So the final position of the image will actually change. So you're able to understand now who is actually who is deciding the angle to which the light will actually bend. It is the refractive index of the light and the material as well. Are you able to understand? So that is the reason why it is dependent on wavelength. Answer is it forms at 3 different points. If they ask you the reason, it is because of the wavelength. That's it. Clear? Yeah.
Okay, sir. So just one more question, sir. So if I put white light, I will get it at 3 different points because white light has red, blue, and green in it.
Yes, it should happen. It should happen. That is why generally we use lights which are of single wavelength, which we call them as monochromatic. I'm not sure if you have heard this word. So monochromatic light rays are generally light rays which have only one focal length associated with them. White light is not monochromatic, it is polychromatic because it has multiple wavelengths associated.
Okay, sir.
But yeah. Define the power of lens. See, according to your textbook, it is a reciprocal of focal length. One student uses a length of focal length 50 centimeter and another of minus 50 centimeter. What is the nature of lens and power used by each of them? So what is the focal length of the first 50 centimeter? What kind of a lens is this? Con?
Convex lens.
Convex lens.
So what is going to be the power of this guy? 100 by 50?
2 diopter.
2 diopter. Yes.
What?
F2 is going to be minus 50. It is going to be concave. What is going to be the power? It is going to be minus 2 diopter. Clear? So power of lens definition, you will get 1 mark. And nature of lens and this put together, you will get another mark. So let me check. Yeah. Next. So draw the ray diagram showing a light through a glass slab, making an angle of refraction and the lateral shift suffered by the light ray while passing through the slab. You know how to draw it?
Yes, sir.
I think I've taught this. So when you take the ray here at the point of incidence, when the ray is traveling, it will travel towards the normal. At the second point of incidence, it will go away from the normal. And when you extend the incident ray, you can see that the emergent ray and the extended incident ray will be parallel to each other, right? So while you're drawing the diagram, you need to mention the angles also. R1, here the angle is R2, and this angle is going to be the angle of emergence. Is that clear? Now the next question is the refractive index of the glass for light going from air to glass is 3/2. So the refractive index of this glass is 3/2. Find the refractive index of air for light going from glass to air. So what is going to be the refractive index?
2/3.
By 3.
Just a reciprocal, no? So refractive index of glass with respect to air is 3/2. So refractive index of air with respect to glass will be 2/3. It's a relative refractive index. Next. Name the spherical mirror which is used for shaving mirror.
Concave.
Concave.
Concave. Rear view mirrors.
Convex.
Vex. What about the other one?
Concave.
Concave.
Concave, because it can divert, it can spread the light more. So write any 3 differences between real and virtual image. Tell me. Real, virtual. So what did you guys write? Real image can be obtained on screen. This cannot be obtained on screen. Okay, next. So when will you have a real image in the case of reflection or refraction? Reflected or refracted rays actually
Actually.
whereas here reflected or refracted rays meet virtually. Then what else is there? So real images are always inverted and virtual images are always erect. So these are the differences. Am I right? Got it? What should be the position of an object with respect to focus of convex lens of focal length 20 centimeter so that its real and magnified image is obtained? So what is the meaning of it?
It should be placed between the focal and the center of curvature.
So it should be placed between the focus and the center of curvature because they're expecting a real and magnified image. Had they expected virtual and magnified image?
Between pole and, optical center and focus.
Center and focus.
Correct. So this is a simple question. 33.
So like for the previous question, should we mention like it should be placed between 20 centimeter to 40 centimeter, or if we mention just focal length and center of curvature is enough?
Focal length and center of curvature is a theoretical part, but with respect to this question, you need to mention the 20 and 40.
Okay, sir.
So student wants to project the image of a candle flame on a screen. which is placed in front of a mirror by keeping the candle flame at a distance of 20 centimeter from the pole. So what is this 20 centimeter guys?
Object distance.
So U is equal to, how should I take it?
Minus 20.
Minus 20.
U is negative, yes. Which type of mirror should the student use?
Concave mirror.
So first one, the answer is concave. Find the, actually there is a mistake. It is not magnificent, it is magnification. I hope you guys understood it. Find the magnification of the image produced. For that, I need to calculate, no? So how do I calculate the magnification?
So no, yeah, it's minus 4.
V is 80, no?
Yes,
sir.
sir.
So magnification of a lens is how much? V by U. So 80
It's
divided
a
by
mirror,
minus-
sir.
Sir, it's 20
Mirror.
meter or 20 centimeters?
1 minute, let me check. It should be 20 centimeter actually.
So
Or
because
this-
in exam, solved it using 20 meter.
Okay, you will get marks for it, don't worry. So since actually this should have been meter and this should have been in meter, or both should have been in centimeter. Anyways, you will get marks for this question. I'm giving marks for everyone. Okay, so it is going to be +4 then. Am I right? So magnification will be +4. Find the distance between the object and its image. So obvious.
100.
Why will it be 100? Did you do 80 minus of minus 20? One minute, wait.
Oh, yes, sir.
1 minute, wait. A student wants to project the image of a candle flame on a screen in front of a mirror by keeping the candle flame at a distance of 20 centimeter from its pole. Okay. So V is means the virtual image is formed. Magnification +4. Here the answer is given as 60.
So magnification should be minus 4, right?
That's what, sir.
Should have been
Shouldn't
minus-
V be negative?
Yeah, it should be negative. That's what I was thinking. So V is negative actually. So minus of minus 80 divided by minus 20. That should be minus 4. It will be an inverted image.
Yes, sir. And then for this third one, I got, third one I got 60 centimeter.
60.
So did I, sir.
Yeah, that's right. Because they use the word screen. Screen means it's a real image. He has captured it. So 80 is the image distance, 20 is the object distance, is going to be 60. Okay. Next. Optical center of a spherical lens. So what is the optical center?
So
There's a
I wrote it
point-
as a point in the lens where light passes through undeviated.
Okay, you can define it like that also, but it's basically the center of the lens. Okay, center of the lens is
Okay, sir.
it's called as the optical center. See, when that is right, what you wrote is right. So divergent lens of focal length 20 centimeter. So there is a divergent length of focal length 20 centimeters. So what is the value of f? Minus or
Minus-
plus? Minus 20. At what distance should an object of height of the object is equal to 4 centimeter placed on the optical center of the lens so that its image is formed 10 centimeter away from the lens? So what is going to be the answer? So H naught is this plus 4 centimeter. So where is the image formed? So V is equal to, it forms a virtual image. So it will be minus 10 centimeter. So now can you tell me? 1 by V minus 1 by U is equal to 1 by F. For unknown, you should not use any sign convention. 1 by minus 10 minus 1 by U is equal to 1 by F is minus 1 by 20. So 1 by U is equal to 1 by 20 minus 1 by 10. 10 minus 20 by 200. So U will be equal to how much?
Minus 20.
So the object should be placed at a distance of minus 20 centimeters for this image to be formed. Okay. Then what are they asking? Find the size of the image also. So magnification is B divided by U. So B is minus 10 divided by U is minus 20. So it is going to be half. So half is equal to HI divided by H naught. So H naught by 2. So height of the image will be 2 centimeter. It should be a diminished one. Correct. So can you draw the ray diagram for this?
Yes, sir.
So how will you draw? Tell me, where should I place the object? So if I place the object over here, if I
It should
call
be
it
on the
as,
focus.
okay, okay, if I place it on the focuser,
Yes, sir.
I'll keep it slightly at a greater distance. If this is going to be AB and this distance is going to be 20 centimeter, right? I'm taking a ray parallel to the principal axis. After refraction will pass, diverge like this. So where will it pass through? It will pass through the foot of the perpendicular. Am I right? So where can you take the other ray to be? The other ray will be passing through the optical center. It travels undeviated. So this is where both are going to meet. This is going to be A dash, B dash. So this will be 4. This will be of height 2. Clear? And what is this distance going to be? It is going to be 10 centimeter. Good. Shall we proceed? When the ray travels from one transparent medium to another, it will change the direction in the second medium. The extent of change in direction that takes place in pair of media actually is expressed in terms of the refractive index. The value of the refractive index for the given pair of media depends upon the speed of light in the media. The refractive index of 4 substances P, Q, R, and S are 1.5, 1.36, 1.77, and 1.31. The speed of the light is maximum in substance. In 2 seconds, you can say the answer.
Yes.
It's the rarer medium. Similarly, if medium 1 is vacuum, right? If medium 1 is vacuum, then the refractive index of medium 2 is considered with respect to 1 as
Absolute refractive index.
correct. The refractive index of water is the number you need to remember.
1.33.
4 by 3, which is 1.33, correct. The speed of light in air is, it's a simple question, 3 into 10 power 8 meters per second. The refractive index of quartz.
So I didn't
That-
attend that question. It was
No
only
problem.
given any 4.
Any 4, no, that. Anyways, the answer is more. This has something to do with remembering the value. So it is actually more than that of alcohol. Right. So I think we are done, no?
Yes,
That's it.
sir.
Okay. So the next topic we are supposed to discuss is current electricity, but I believe that most of you have exam tomorrow. Is that right?
Yes, sir.
Okay. Okay, then we'll wind up. Okay, we'll prepare for that as well as the test we have tomorrow. Okay. I'll see you all.
Thank you, sir.
Yeah.
Thank you, sir.